Aha, works. Hello. Well, tonight we are going to start a new journey. At the end of this journey, we will be having a compressor. Yeah, a compressor which is, a lamellar compressor, a rotating vane compressor to be exact. Well, it's like that one there. The principle, etc., can be seen. Yeah, and in this case, the journey will be more important than the goal. Yeah, you can buy such compressors pretty cheaply, but that's not the point. The point is to make one. Yeah, to go through the thought, etc. of this thing. Okay. Well, to guide me through this journey, I made a plan. Wow. Here it is. The first thing about this plan is, of course, this rotor, which we have in there. Well, the rotor is, housing six of those lamellar things, which then rotate around. Yeah, well, the principle should be pretty clear. And then we have also these bearings at the ends, and then we have a oil pump there. Well, this is not going to run dry because I'm going to make the vanes from steel. You could use something like Teflon, PTFE for those, but I don't like the material. It's not very easy to machine. For me, tool steel is even easier than Teflon. Yeah, so it is. And and then you just rotate it. Well, the oil has two functions. First of all, it lubricates the whole system, and then it also creates an oil pressure there inside that pushes the blades against the cylinder walls. Well, that's one. Okay. Well, tonight, because we are starting, let's start easily. So we start with that part of the pump. It's probably the easiest one. It's just a round disc with eight holes in it. And yeah, so let's go back to my garage, to my workshop, and start dealing with that part. Yeah, see you there. Welcome to my workshop. So, the plate, the disc we are going to work with is this. This is some 70 millimeter in diameter. It's not cold rolled steel, it's something else. I really don't know about the material, what this is. I already made this surface. It's very straight, very fine surface at the moment. So my intention is to put it into here, in the chuck, like that. But in order to get it securely and straight into the jaws, I first wipe off these so that there are no chips in there. And then I put this here, the readily machined side, against the jaws like that. And then I push it with my tailstock a little bit. This is just to ensure that it really is there against the jaws. And then we, yeah, okay, then I just tighten it there. Well, there you are. I did this operation to make it sure that the front side and back side become parallel. This chuck is really accurate, but you can always place your workpiece wrong there, so that there are some chips under there, or it is otherwise tilted. Okay, so now first I'm going to use this VNMG tool, and now the first thing is to check that we have clearance everywhere, because this one can bang into the jaws, and there you go. Okay. I'm just checking about clearances here. We should have everywhere. Yeah, we have clearances. So now I tighten the tool, and since I'm okay, I move this like that. Since I'm always, when I'm facing, I'm using the top slide for feeding in. It's more accurate, and this one is this is so coarse that it's almost impossible. Not impossible, but it's very hard to feed in, let's say, 1/10 of a millimeter. Not to talk about smaller distances. So now I lean the edge of the tool against the workpiece and tighten the slide, the carriage. Now I can feed with this one, and the carriage stays in place. It's locked there, and yeah. Then let's ensure that we have the correct feed direction. Yeah, it's wrong feed direction, and it's okay. Well, at first I'm going to feed this in manually, so it won't matter. But the last pass I'm going to use another type of tool, and I'm going to use very, very slow feed, etc. You will see how this goes. Now, let's start facing this surface first. Well, this is by no means the final surface. The thickness, the goal here is 10 millimeters. And now I will measure this. How much is it at the moment? like that, and yeah, it's quite tight. Okay, let's see now what we have here. Seems like we have 11.08 maybe. Yeah, 11.08 millimeters. So I will take it down to so that we have 0.1 millimeter to go. Well, now we have about 0.7 millimeters to go here. I will change the tool now. It's no 700ths of a millimeter. Sorry about my misplacement of the decimal point. Okay, I'm going to use this tool to do the rest, and now we need to set this up so that I think we need to extend it a little bit, because this is now so deep inside that it will actually, it can hit the jaws, and that would be really bad. Okay, now I extended it a little bit, and now I need to check that we have the room here again. Well, seems so that, well, we have a few millimeters around there. Maybe it's okay. Well, we have a few millimeters, that's okay then. I locked again the carriage, and now I would like to touch it somewhere. Let's touch here, and this is a very delicate operation in a way that I need to be very careful here not to over touch it. Okay, I think we are there. A little bit more. Well, it's touching. Okay, and now I'll reset my dial here on the on the top slide, and then, well, let's see now. I would like to go in here in the center a little bit. That's the, we should be there. Let's see if I can feed this out. Yeah, it's feeding now. And now, okay, let's have something like this here. Oh! Like that. And now this is really peeling very, very small amount of steel, something like 700ths at the moment. Should be. Well, let's see. I will measure it after this one. But what this produces is a really straight surface with a very good surface finish. This is like steel wool. Ah, and yeah, you can see something on the surface, but you definitely cannot feel anything there. So now, this should be now on final dimension. I will measure it before I dismantle this. Let's see now. It should be very near 10 millimeters. Oh yeah. Ah, that was not a good measurement. That is a good measurement now. Oh, it's so slippery. Well, we are 500ths of a millimeter under. Well, such things can happen. Well, what this now means is that this is 500ths of a millimeter undersize. Well, it doesn't matter really. This is just a cap to the other end, and well, it's more important to have a very good surface here than have it like exact dimension, the thickness. So that's good. Okay. Yeah. That there is the result of the lathe job we did. The workpiece, as you can see, it's a very smooth surface, and the surfaces are parallel, within 200ths of a millimeter. Well, there is some thing about facing like that. You can overdo this very easily, like I did. So if this would have been critical dimension, that workpiece would be wasted. So now, well, the next step will be happening in my milling machine. We are going to make a bolt circle into that one, and in addition there will be oil passage for the oil pump. Well, so let's go to our milling machine. Well, welcome to my milling machine this time. Well, this is my dividing head where I have attached this workpiece now. Well, it's centered. I have dialed it in axially, and I also have dialed it in so that it doesn't wobble at all. Well, inside 200ths of a millimeter in every thinkable dimension. And well, this material is surprisingly accurate. Well, as well, it's accurate. And then now I have also dialed in, I have been sweeping around with this, around here. And I have made it so that the spindle center is in the center of this workpiece. Oh yeah, okay. So now we are going to make a hole pattern here, 8 holes around, so 45 degrees apart each of them, and the radius is 30 millimeters, which is relatively easy to dial in here now. And well, then I have this, this is a 4 millimeter drill, and there will be 4 millimeter holes, 8, and then recesses for bolts that go there. This is, I designed it for 7 millimeters. Unfortunately, I don't have a 7 millimeter end mill, but this one is 7.75, which is okay. it will be a little bit larger. It leaves a little bit less material on the outside, but that's okay. Actually, it's not too bad there, as long as it doesn't poke through. That would be bad. So now it's just to dismantle this thing here. Okay. Ooh. So, 30 millimeters. That was 10, 20, and 29. That's 30. Yeah. Let's see how it looks. Whether the place is about correct. Yeah, there it is. And now it's just to drill. Well, the speed then. Our speed is a little bit... Well, I need to switch this thing on first. And let's see. You cannot adjust the speed if this thing is not running. So, well, first of all, high gear. Like that. And then we need, I should say 400 RPM is correct. I'll take this away a little bit. Okay. That's too slow, actually. 400. I think that's our speed. Well, then I just collect my things away from here and start drilling these damn holes. Well, that was totally uneventful. Well, exactly the way I like it to be. So now we have 8 4mm holes in there and a lot of chips here, which I now take the most of these away. Well, next the recesses. That shouldn't be too hard. I have to switch again to low gear because otherwise I cannot get this drill out from here. Like that. Then we just take the drill out. And these need to be on a specific depth. So 4mm is the depth of these. I need to set the dial here in the X direction dial. Oh, now it's okay. Should be. Okay. And this should be a lot easier to do. It should be. So let's go on with this one. Well, another uneventful operation which is really good. I don't like surprises here. So now let's take this end mill away from there. And well, the next hole is a little bit different. This dividing head, well, it should be, well, it's also a radial, one hole in a bolt circle, but it's it should be 22.5 degrees, so right in between those holes. Well, this dividing head cannot do it with direct indexing, but lucky me, that hole is not to be that exact. The location, well, if there is now this scale here on the rim, these graduations, I can use those. Here is the 0, and now I should turn this 22.5 degrees. Wow. Okay. About there. I lock it in place. It should be quite in the middle of... and then the distance from the center is 7.1 millimeters. Well, let's go to the zero first. There is our zero, 7.5. So that's 5, 6, and that's 7, 7, and 10.5. 0.1. 7.1. And this is all the way through. Through it is. Wow. Okay. Well. So now let's remove it from there. There you are. Wow. Oh. Well, it's not too shabby. We need to take care of the burr here. And yeah, but that's not too bad to do. Yeah. Okay. So, well, this is okay. Well, now that we are ready with the... What? Ah, sorry. Now that we are ready with the milling operations, for that workpiece, we'll still have something to do for that. We need a long hole for the oil passage from the side of this hook, and then we need to de-burr it. As you can see, there is a lot of de-burring to do. Every hole has a burr in it. So, and this all happens in my drill press, so let's go there and just do it. So now let's de-burr this hook. Well, every hole has here quite a hefty burr. I'm using this type of tool to get rid of that. This can be used manually like this. You just have to take care that you don't overdo this. So it's so very easy to make a chamfer. So, and this is, as you can see, really fast. Yeah, didn't take long at all. So, and well, that we will do later on. And then this side, the same thing goes here. Yeah, we are done. Almost. We still have something. Well, there is a burr in the thread, in the hole. Well, that one I think I can get rid of using maybe this one. I think, yeah, this is so sharp you can do it like this. just rolling it with your fingers in there, and it will take care of. The burr is so thin that this works really well. The end mill didn't leave a lot there. Yeah, and yeah, I think we are there. Yeah, some shop air. Yeah, okay. And this is how it looks. Yeah, okay. Well, now as you remember, there was this hole here, and now this should have a thread. Yeah, okay. I will use my hand drill to make that thread. Okay, now it should be tight enough. Oh. Wow, it almost went through. Okay, let's see if I can get it through. This was... Oh man. You have to be careful when you restart this. Yeah, there you are. And soon it grips. There you are. Done. Yeah. So now, the oil passage from this side to that hole inside there. I adjusted this direction of the table so that it meets the hole there, okay? And then, my next step will be to make here small dent. This is now 5 millimeters, and we are 1 millimeter high here. It's not very easy to estimate these distances. Okay, now it should be. Yeah, now it's quite accurately there. And then well, let's see how fast is this. Wow. And now let's see, this might wander. So it didn't. Good. It didn't wander, which is good. Now we have a dent there. Then I lubricate, give it some lubrication, and then we drill the hole. Now it made it might be very near. Put a lot of oil into there. Yeah. It's true. Yeah. Wow. It made just a faint vibration when it went through. But it also gave me a pre-warning that now it's going to go. And yeah, okay, we have a 3 millimeter hole there. Now, next step, 6 millimeters, not too deep. Let's see. Now it is 14 millimeters. 15. A little bit more. Okay. 15. Enough threads for that one. Yeah, okay. Now it's good. Oh yeah. So, I think we are ready. Oh, with this one. Oh. Yeah. Okay. There you are. So now that thing, that part of this rotary vane compressor is ready. Well, in the next episode we will be making some other part, but you decide what the part will be. Just put in the comments what would you like to be produced, made the next. Well, yeah, okay. Till then, bye!